Welcome students, welcome to my next class. In our last class we discussed about drawing sheets and pencils, drawing board and basic engineering drawing definition and the basics. Okay, so now today we are going to discuss about the remaining drawing instruments. Of course, we come across with T-square and mini drafter also. Okay, there's a small concept left in drawing sheets. Okay, see, in last class in drawing sheets I told you one thing. See, these are the drawing sheet sizes. Okay, so to know about, see how we standardize the A according to the area of the sheet. Okay, so there is a common thing in between these sizes. The common thing is known as aspect ratio, and that aspect ratio is 1:√2. Common thing is 1:2. If you see, if you consider 841 is the 1, okay, and 1189 is the √2, in that aspect this thing will change. Okay, so next, this is the aspect ratio 1:√2. Then how, sir, how this if it is the aspect ratio, how A0 is discovered as 841 multiplied by 1189? As you said, A0 is nothing but according to the 1 meter square. Okay, now last class I discussed about this thing. The A0 sheet is 1 meter square. Okay, and A0 is useful for planning purpose. If you see civil engineers and building plans and elevation, okay, to draw all these things we need A0 sheet, and for A2 means our regular drawing sheet. A3 is type, A4 is for all documentation purpose, all documentation purpose. Okay, next, so for how A0 is described as 841 multiplied by 1189. If it is 1 meter square, you can, in the aspect of length and width ratio, you can say 1:1. But why it is 841 by 1189? Why? Because of, if this is the drawing sheet, this is known as X0 and this is known as Y0, and this X0 and Y0 ratio must be in the aspect of 4√2 and 1/4√2. Why, sir, only 4√2? Why? Because of the standard documentation purpose we are using A4. For the standard documentation purpose we are using A4. That's why we mentioned here 4√2. If it is A3, then you can use 3√2, but it is 4√2 only. Why? Because of, according to the A4 sheet. Why? Because of, for all documentation purposes we are using A4 sheets. That's because of, it is 4√2 is to 1/4√2. Okay, so this is the aspect ratio and this is the drawing sheet. And you can ask me one thing: if you go to purchase any A4 sheet, any A4 bundle, on that bundle, see, this is how the bundle looks like. This is how the bundle looks like. Okay, sorry, this is how the bundles looks like. Okay, in this bundle, at this position, they will indicate 75 GSM, A4 210 by 297 mm square. Sorry, mm square. What is this means? What is this GSM? Okay, what is the meaning of this GSM? So the meaning of GSM is nothing but grams per square meter. Grams per square meter. Okay, this is grams per square meter. And see, all these things are interrelated. If this is A0, see, A0 is 841 multiplied by 1189. If you bisected, I mean, if this is the sheet, okay, if it is folded, then you will get A1. Next, if it is folded like this, you will get A3. Next A3 is folded, then you will get A4. Like that it will be there. Okay. So I said A0, A1, A2, A3, A4 all are interrelated. So can we obtain A2 sheets from A0? Yes, of course. Then can you obtain A3 sheet from A0? Yes, of course we can obtain. But how can we obtain? See, if you want to obtain, okay, I will give you one question. See, how many A7 sheets can be obtained from A3 sheet? Like this the questions will be there. You will get questions. How many A7 sheets can be obtained from A3 sheet? So how to solve this? The solution is here. Okay, so how many A3 sheets can you obtain from A7? So just 2 to the power, what are the sheets you need? A7, so that's why 2 to the power of 7, from which A3, so minus 3, 2 to the power 7 minus 3, that is 2 power 4. 2 power 4 means it's nothing but 16 sheets. So how 16 sheets. So how many A7 sheets can be obtained from A3 sheets? It's 16 sheets. Okay, so this is how you will get questions. Like in the same way, how many A4 sheets can be obtained? How many A4 sheets can be obtained from A0? It's simple, 2 to the power of 4 minus 0, it is also 16. Okay, how many A4 sheets can be obtained from A1? It's 2 to the power 4 minus 1, it's 2 cube, that is equal to 8 sheets. Okay, like this the questions will be there. Okay, in this manner you should think. Okay, the questions will be this much creative. Sir, who gave you all these standards? The standards are given by Bureau of Indian Standards, BIS, Bureau of Indian Standards. Okay, so according to this only we made all these documented. Okay, so this is how it is, and please note it down. So the next drawing instrument is set squares. So what is set square? See, for each and every instrument there is a purpose. For T square it is to draw horizontal lines on a drawing sheet. Okay, and for if you consider T square, it is to draw horizontal straight lines. If it is a drawing board, to support T square via ebony edge and to give support to the drawing sheet. And drawing sheet purpose is where you can draw graphical and schematic diagrams. These are the purposes, and pencils also have specific purposes. And for set square also there are certain purposes. The purpose of the set square is to indicate angles. Okay, so there are two number of set squares. One is 45 degree set square, and another one is 30-60 degree set square. Okay, there are two set squares. One is 45 degrees and another one is 30 and 60. Okay, so if this is the drawing sheet, if you put T square here, you can easily draw straight line. But if you want to draw vertical line, how can you use? You might be thinking that I will put T square here, this will be the head, this will be the blade, so with the help of blade I will draw vertical line, but it is wrong. You should not do like this. Why? Because for drawing board, ebony edge is located at the left hand side of the drawing board. So here the drawing board will be there and ebony edge will be there. So according to this ebony edge, you will place this head of the T square in the ebony edge. Okay, such type of facility is not presented here in this side. That's why we cannot draw vertical straight lines. To draw vertical lines, what you should do, you have to place, in olden days, you have to place t square here. Then after that, you have to place one of the set square here. Then you will be easily draw vertical lines. So with the help of set squares, you can indicate angles and you can draw vertical lines also. Okay, both are possible. Okay, and you will get some questions from this set squares. Okay, like which of the following angle is not possible with single set square? With single set square. A 45 degrees, B 30 degrees, and C 60 degrees, and D 75 degrees. Okay, so like that the questions will be there. See, which of the following angle is not possible to indicate with single set square? With single set square, see, if you consider 45 degrees, with the help of this 45 degrees set square, you can be able to indicate 45. With the help of 30, 60, you can be able to indicate 30 and 60, but 75 is not possible with the help of these things. Okay, with the single set square. Okay, so he will ask you another question like this: which of the following angle is not possible to indicate with set squares? That means with both. So 20 degrees, 15 degrees, 30 degrees, 90 degrees. So which of the following is not possible to indicate with set squares? Two set squares we have to use. Okay, you might be thinking 15 or 20. Okay, actually it is 20. 20 is the right answer. But with the help of two set squares, we cannot indicate the angle 20 degrees. Sir, can we indicate 15 degrees? Yes, of course we can indicate 15 degrees. Suppose just now I said this is the blade. Here if you place 45 degrees set square and again you place 30, 60 set square, that means in a plane it is 90 degrees. If you place 45 degrees set square and 30, 60 set square, the remaining angle will be 15 degrees. Why? Because of here it will be 45, it will be 30. So that you can, so that 15 degrees also you can indicate, but 20 degrees is not possible. So here we can say with the help of single set square, you can, with the help of single set square, we can indicate the angles of 45 degrees, 30 degrees, 60 degrees, 90 degrees, like this. With the help of set squares, you can indicate any angle in terms of the multiples of 15 degrees. In terms of the multiples of 15 degrees, like 15 degrees, 30 degrees, 45 degrees, 60 degrees, 75 degrees, 90 degrees, like that. Okay, and so on. Okay, this is about set squares. You might get a question like this from the set squares. So the next drawing instrument is compass. Okay, with the help of compass, what you can do, you can draw, might be you are saying you can draw arcs, you can draw circles. But as an IES aspirant, you should not mention these things. You should mention in technical way. Okay, what is the technical way? Compass, the purpose of compass. The purpose of compass is to draw the locus of a point, which is equidistant, from a fixed point. This is the help of compass. With the help of compass, is it? No. There will be a locus of the point. That locus of the point P is there. Okay. It should be equidistant with a fixed point in either sides. And you will place your compass here. You will place your pencil here. Then you will be able to draw a circle. This is what compass is. Then what is the help of divider? Divider, what is the purpose of divider? To transfer the lengths. Okay, to change lengths from one place to another place, you can use divider. Okay, this is the compass. Compass are two types. One is big compass, to indicate very big radius and very big arcs to draw. Okay, and another one is bow compass, use it to draw very small locus of the points. Okay, and in your examinations they can ask you with the help of compass, which following purpose is not possible. Okay, so A, you can draw arcs, and B, you can divide angles, and C, draw locus points, and D, transfer lengths. So the answer is transferring the lengths from one place to another. Why not, sir? We can put compass and you can take it like that, you can think. Okay, but it is not possible. With the help of divider only it's possible. Okay, clear? So this is the answer. If it is with the help of divider, then so what are the remaining drawing instruments? It's clamps. The purpose of clamps is to hold drawing sheets on drawing board. That's it. Drawing board. Okay. Next, protractor is there. Of course, you all might have known about these things. And another one is French curves. The purpose of French curves is to draw symmetric or unsymmetric curves, such as conic sections or roulets. Conic sections or roulets. Okay, and next thing is eraser, you know, and protractor, you know, to indicate the angles which are not possible with set squares. Okay, so I will write it. With the help of protractor, what you can do, you can indicate the angles which are not possible with set squares. Is it now? With the help of set squares, you can be able to indicate specific angles. But with the help of protractor, you can be able to indicate very small angles also. See, with the help of set squares, you cannot indicate 5 degrees, 7 degrees, 17 degrees, 88 degrees like this. You cannot indicate with the help of set squares, but with the help of protractor, you can indicate all these angles. Okay, so this is the purpose of protractor. Okay, now we completed the purpose and the concept of drawing instruments. Okay, clear? So after completion of this total basic concepts, I will give you we will have a session regarding only problem solving and only to solve the questions which are given in previous papers. Okay, we will have a session for 30 minutes for sure after the completion of these basic concepts. Okay, we already come across with drawing instruments. Now the different type of lines and its applications and their descriptions are here. Okay, so why we need to learn about these lines, I will let you know. Why? Because of each and every line has its own application, okay, and own advantage. Okay, so in olden days, I already told you, it is the language of engineers. Okay, you don't need to write so many descriptive things. If this line is there, if this kind of line is there, then that means the purpose and the application is like this. Like that, they used to think like that. Okay, so let's start our lecture with the first kind. The first kind is, it is continuous thick line. Okay, the continuous thick line is used for visible outlines and visible edges. That means a normal diagram. If you draw a normal diagram, these are the visible edges and these are the visible lines. To draw this type of visible lines and visible edges, we used to use this continuous thick line. Okay, clear? And we use HB pencil to draw this. Okay, and next, continuous thin. These continuous thin lines are useful for dimensioning purpose and projection lines purpose and to draw ladder lines. Like suppose if I want to give dimensioning for this purpose, for this specific length, then what I should do? I should draw one dimensioning line. Without the help of dimensioning line, I cannot indicate dimension of the particular length. So to draw dimensioning lines or to draw ladder lines, we use continuous thin line. Okay, the next thing is continuous thin freehand. It is useful in the application of boundaries of limits and interrupted views. Boundaries of limits and interrupted views means, suppose you might have all gone through this. If you are going to indicate a very big shaft, is there which is of nearly 1 meter, nearly 10 meters or 1000 meters. You cannot draw the whole thing here. So for this purpose, what we will do is, in engineering norms, we put it like this. See, these are the lines that indicates. Okay, that indicates it's a very big shaft, but we are able to show it like this only. Okay, we are able to show it like this only. That is the meaning. Okay, and the next thing is continuous zigzag. Continuous zigzag means it's for long break lines. Suppose there are shafts which are which are broken. Okay, then we use continuous zigzag lines, and not only here and in the purpose of drawing rivets also. You might have, mechanical engineers might have known about this concept, drawing of rivets. In the concept of rivets, we use zigzag lines. Okay, and next, I mean in terms of you can say, while drawing of riveted design, in the purpose of riveted designs, you can use continuous zigzag lines. Like that also you can mention. Next thing is dashed thick. Okay, this is the dashed thick. Dashed thick means like this. Dashed thick and dashed thin. This is the dashed thin. Okay, both these things are useful in drawing hidden outlines and hidden edges. So what are the hidden outlines and hidden edges? Suppose there is a three-dimensional book is there. This is the three-dimensional book. Okay, you are able to watch this, this, and this. Is it? But the book is having actually 6 number of sides. Okay, suppose if I take this book, it is having, if I place it like this, you will be able to watch this side, and only this side. You are not able to watch this bottom, this one, and this backside one. But even if you are not able to watch those sides, watch the edges, but still they are there. To represent those things, you need to draw dashed thin and dashed thick lines, which are known as hidden lines. Hidden lines means the lines or the edges to hidden lines are useful. The purpose of hidden lines are to indicate the edges which are hidden, which are not visible. Okay, but will be there. Okay, next, the chain thin line. The chain thin lines are for indicating central lines. See here, I have indicated one central line. This is the chain line to indicate central lines and the line of symmetry. You know line of symmetry. What is line of symmetry? If there is a parabola, it is a symmetric curve. That means if you draw a line here, the distance between here to here and distance between here to here. See, this is point 1, this is 2, this is 3. The distance between 1 to 2 and distance between 2 to 3 are equal. This is called as symmetry. Okay. So next thing is chain and thicket ends is used for cutting planes. Cutting planes means, suppose there is a triangle. If I want to cut this one, then I have to use a cutting plane like this. Okay, the ends must be thick. Okay, you may have come across in sectioning of solids. Okay, next thing is chain thick line. Chain thick line. The chain thick line is indication of lines where the special treatment is required. Where the special treatment is required and there is special purpose machine elements are there. Okay, to indicate the thing, we need to use chain thick. Why? Because of, and for example, suppose you might have gone across with production drawing, limits, fits, and tolerances. Or in assembly drawing also. In assembly drawing, we used to, suppose not assembly drawing, just take this cap. See, this cap is there, this pen is there, and it should be fitted here. It should be fitted. Okay. So for the purpose of it, here they use some surface roughness here. They might have some surface roughness here. Okay. To indicate that surface roughness, they need to use the special treatment lines. Okay. So next, double dashed lines. Double dashed lines are useful in, see, double dashed line means line dash, small 2 dashes, dash, 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 dash. Okay. Double dashed line is useful in indicating centroidal lines. You know centroidal lines, the center of gravity lines. Okay. The center of gravity and the centroid lines, where the total area or the total weight of the body will get concentrated, or nothing but centroidal axis. That means nothing but, see, suppose the pen is there. If you place it here, it will fall down. Okay, but if you place it here, it is staying. Okay, why it is staying? Why? Because of the whole mass or the whole weight of the body is located at this point. In that point, I gave my support. Okay, so to indicate that type of points, we use double dashed chain lines. Those are called as where it is used in centroidal lines, to indicate centroidal lines. So this is about lines and their applications. You might get a question from this also. Okay, you need to study thoroughly. Okay, clear?
That's it.
So, okay.
Okay.
So the next topic is dimensioning. Okay, what is meant by dimensioning actually? Okay, dimensioning is also an important part in the engineering drawing journey. Okay, so you might get one or two questions in this particular topic. So better to study that. Okay, so what is the definition of dimensioning? What is the purpose of dimensioning? The purpose and definition both are same for the dimension. Okay, so now what is the purpose or definition of the dimension? We will see. The purpose of dimensioning is to indicate the distance or size or height or an object from one position to another. Okay, is it now? Because of to measure the distance from one position to another position, we need dimension. Okay, it tells us how it indicates the distance. Okay, suppose if you see the distance between your home and your college, you can indicate this one like this. There should be one dimension. Okay, or if you purchase a mobile, in the mobile also they will give you certain dimensioning. The screen guard, the screen, everything will be this much of inches, this many centimeters, like that they will indicate. Okay, so dimensioning is nothing but the indication of distance from one distance of a body from one position to another. Okay, so here there are two types of dimensions. One is align the system of dimensioning, and another one is unidirectional system of dimensioning. Two dimensions are there. One is aligned system of dimensioning, another one is unidirectional system of dimensioning. So how these are classified as? What is aligned system of dimensioning? What is unidirectional system of dimensioning? See, first of all we see aligned system. Let us consider this is a body. It is having 20 mm, 50 mm, 25 mm, 20 mm, and 30 mm. Here we need to indicate dimension. How will we indicate? With the help of extension line. These are called as extension lines. Perpendicular to extension lines, you will draw dimensioning line. See, suppose you are going to indicate the distance between here and here. This is the position 1, this is the position 2. If you here, you are indicating the dimension between position 1 and position 2. For this, what you have to do, from position 1 you have to draw an extension line. From position 2 also you have to draw an extension line. Then perpendicular to it you have to draw dimensioning line. While indicating the two extension lines, you have to put arrows like this. Okay, and here you will mention about 20. This is a right system of dimension like this. See here you will indicate 20. This is 50. Extension line and dimensioning line. Here also extension line. And line. Okay. So, is there any specific reason for arrow marks? Why? Because of, see, indication of arrow marks is most important in dimensioning. It plays the key role. Okay. And is there any standardization? Yes, there is a standardization. IES standards are there. According to the IES standards, you have to indicate arrow mark closed and filled. It should be closed and it should be filled. It should not be open like this, or it should not be closed like this. Even if it is open, it should be filled. Okay, but it is also wrong. It is also wrong. This is the right one. Okay, and arrow mark, the arrow should be 1:2. The height is 1 unit. If the height is 1 unit, then the length of the arrow will be 3 units. Okay, the ratio of height and length of the arrow should be 1:2. Okay, so this is the right system of dimensioning. Okay, then what about the unidirectional system of dimensioning? Let's see. This is the unidirectional. Okay. Take the same diagram. Okay. Here the dimensioning will be, this is 25, 20, 25, 50. Okay. So here, this is the position number 1, 2, 3, 4, and this is the 5. So to indicate between position number 1 and 2, what we have to do? Extension lines are common. Dimensioning line also common. But the indication of 25 will be in between this. That means here the dimensioning line is not continuous. Here the dimensioning line is continuous. Please note it down. Dimension line is continuous. Here the dimensioning line is not continuous. Okay, and here this is one. Every time arrow must be closed and filled. Then you can ask me, sir, how is that differentiated like this? Why aligned system is on top of this dimensioning line? Why in unidirectional system the dimensioning is in between, the dimension line is not continuous and the dimensioning of indication is in between? Why? Because of in unidirectional system you will observe the drawings. See where these drawings and dimensioning lines will be there on a drawing sheet. Okay, on a drawing sheet. Suppose if you consider this is the drawing sheet, you will watch drawing sheet like this. That means if it is the drawing sheet, you have to observe drawing sheet like this. So that's why in this direction you are going to observe. That's why the dimensioning is in between this. Okay, but in case of aligned system of dimensioning, you are going to observe the dimensions accordingly to the title block of the drawing sheet. You know, in drawing sheet at right bottom you will have title block. Okay, so you are going to observe dimensioning in the way of title blocks like this and like this. So here, if you want to indicate, you have to indicate it like this. Like this. Okay. Suppose if you consider this is as the drawing sheet, the title block will be right bottom. So from right bottom means you have to observe the drawing sheet from that position and from this position. Okay. From here and from there. But in unidirectional system, like this. Okay. So that's why aligned system of dimensioning is like this and unidirectional system of dimensioning is like this. Okay. The most important thing you need to mention is here the dimensioning line is continuous, here the dimensioning line is not continuous. Okay. So apart from the aligned system of dimensioning and unidirectional system of dimensioning, are there any type of dimensioning systems? So it's not system. The way of indication is different. Okay. The three ways are there. One is chain dimensioning. And another one is parallel dimension. So how the chain dimensioning will be? See, suppose this is the okay. Here the chain dimensioning will be like this. Suppose take it as 25. 20 and 25. Now the chain dimensioning will be like this. Just see here, arrow mark should be closed and filled. 20. See here, the dimensioning is like chain. 25, 20, 20 is like chain. Okay, that's why it's called as chain dimension. But whereas in parallel dimensioning, here it will be this is 25. It is 25, 20. The sum of 25 plus 20 is 45. Next, 25 plus 20 plus 25. It means how much it will be? It will be 70. See, here the dimensioning lines are parallel to each other. Here the dimensioning and dimensioning line both are like one by one. So that's why this is called as chain dimensioning and this is called as parallel dimensioning. Parallel dimensioning, the dimensioning lines must be parallel to each other. Please remember this point. The name itself only tells you how the parallel dimensioning will be. If the dimensioning lines are parallel with each other, then it is parallel dimensioning. If the dimensioning lines are one by one each other, then it is chain dimensioning. Next thing is combined dimensioning. The third one. Okay, in combined dimensioning, what will be there is the combination of both two. Okay, so the diagram will be like this. Okay, so this is chain dimensioning. And here it is parallel dimension. And this is as 15. Here it is as, it's not 15, so 15 plus 20 it will be 35. This will be 20 plus 35. This is the combined dimension. Okay, now we got three ways of indication of dimensions. One is chain dimensioning, where the dimension lines are one by one each other. Here, the parallel dimensioning, the dimension lines are parallel with each other. Okay, next the thing is combined dimensioning. Okay, so this is what about dimension. So the next concept is lettering. Okay. So what is the concept of lettering? To give titling. Give titling to the diagram. Okay. If you made any diagram or drawing sheet, you need to indicate the title. Okay. Otherwise, it is the main thing. Okay. Without giving titling, it won't work out. Okay, you should give titling, which diagram it is. If you draw cycloid, you have to indicate it is a cycloid curvature. If you draw elliptical curve, then you have to indicate it is an ellipse. In which method you have drawn that one, like that also you have to indicate. Okay, so for the purpose of lettering is to give titling of the diagram. Okay, so what is this? How many types of letterings are there? There are two types of letterings. One is vertical lettering and another one is inclined lettering. Okay, in vertical lettering, vertical lettering means the alphabet will be straight. Inclined lettering means the alphabet will be bent, like that. It means it will make some angle in the horizontal. Okay, so suppose vertical lettering. In vertical lettering, you will have for each and every alphabet you will have height, width, and the gap. These are the main criteria for the lettering. So how it is, we don't understand. Okay, I will let you know. Suppose we are drawing the vertical lettering. Okay, we will draw alphabets. We will draw alphabets with vertical lettering of 10 mm height. Okay, we will draw it. For the purpose of this, what I need to do, first of all, I have to draw two lines which are 10 mm apart. Why? Because of the height of the each and every alphabet is same. We are going to draw all alphabets in this thing. Okay, in this 10 mm gap. Okay, for this purpose, I have taken two lines where gap between two lines are equal to 10 mm. Okay. So first of all thing is A. See, for an alphabet the height is 10 mm. That means there will be width also, no? Okay. So what will be the width? So if the height is 10 mm, the width will be 7. So how you got this? By the formula, the width of the alphabet is equal to 3 by 4 into h. 3 by 4 multiplied by, what is the height? 10. Okay, it's 30 by 4, that means nearly 7.5 mm. It's 7.5 only. If you process 7.5, then you will take 8 mm. It's 7.5 only. So that's why I am taking this one as width as 7 mm. So I will make a box with gap of 7 mm. Okay, here in between this box I will write A. How I need to indicate A? In midpoint you indicate a point. Then you draw like this. Okay, exactly this is 10 mm height. At 5 mm height, you need to indicate this horizontal line. Okay, next is gap. Why? Because of immediately after the A, you cannot attach B. There should be some gap. How the gap should be? The gap should be 3 mm for this. So how did you get this? The formula again is 2 by 7h. 2 by 7h. The 2 by 7h means 2 by 7 multiplied by 10. It is 20 by 7. Almost of all 2.9. It crosses 2.5, so that's why I am taking 3 mm gap. So after 3 mm gap, what I have to do? I have to draw a box. Again, it's 7 mm gap. I have to draw this. Okay, so now how to draw B? First draw a 10 mm line. Next, at 5 mm, draw this one. Okay, here you draw it like this and close the curve. But the bottom one should be bigger. See here, there are two curvatures. Top one is smaller and bottom one is bigger. This is the indication how you need to draw lettering. Okay, this is B. This is smaller one. This is bigger one. Okay. Now give 3 mm gap. Again 7 mm. Your hand only you have to draw. Okay. Next give 3 mm gap and 7 mm. Here B will be like this. Okay. Next thing is E. Please listen carefully. Give 3 mm gap and 7 mm box. How you have to draw it is, the smaller one is, the bottom one is up to 7 mm. The top one is 5 mm. That means lesser than the bottom one. And the middle one is lesser than both two. Should be like this. Okay. It should be bigger. It should be 7 mm. It should be 5 mm. And it should be 3 mm. That means, okay, it should be like this. Next, F. Give 3 mm gap. Top one should be up to 7 and bottom one should be lesser than the 7. Next, G. Give 3 mm gap and 7 mm. Draw C first of all. Next, use 7 to not 6. Next, H. H is common. 7 mm is there. No? Draw 2 lines and mid one. G, H. Next is I. You all might be thinking that I am going to take 3 mm gap and again I will take 7 mm. In between I am going to draw a vertical line like this. But this is wrong. Okay. Take 3 mm gap and draw it. I. That's it. Okay. Next, with 3 mm gap, draw 7 mm. Then J. Okay. Next, K. Take 3 mm gap and 7 mm. Please see this. Okay. This is the vertical line. Take 5 mm. Join this. Okay. Next, you might be thinking that I will join it like this. No, it should be joined like this. See how the K is. This is how the K. Okay. Next, L. Up to 7. Next, M. Take 3 mm gap. And join like this. M. Okay. Next, N. Take 3 mm gap and 7 mm. And join like this. Next, O. Just like as C. Next, P. Please see this. This is the P. Okay. Next, Q. First of all, draw O, then indicate this. Next, R. First of all, draw P. Next, from middle, you join it like this, up to 7. Okay. Next, S, the most important and most confusing one. Okay. In exam point of view, you can expect this. Take 3 mm gap from L and take 7. Draw this box. Okay. After this, how you have to draw this as is. This is S. See, two curves are there. The top one should be smaller and the bottom one should be very big. Okay, next T. Next U. Take 3 mm gap and draw it like this. Next D. Okay, next X. Same, take 7 mm gap and join it like this. The Y is different. Okay, take this is the 10 mm gap. Here the Y should be like this. This is the 7 mm. Okay, midpoint of the 7 mm. Take midpoint of the 7 mm, then join it like this. This is the Y. And the Z is common. Okay, so this is how you have to indicate alphabets. They don't ask you to draw anything here, but they will ask you the questions in these alphabets. Okay, how they will ask you at the end of the class, I will make another video especially for the purpose of problem solvation. Okay, by taking previous year questions, I will make one video. Okay, but there I am not visible, only the sheet will be visible, there we will solve those problems. Okay, so this is about lettering. Sir, who gave me this lettering? Why should we draw it like this? Who proposed this one? This was proposed by BIS. For BIS, International Standards of Organization, IES who proposed. Okay, sir, is there any specific typing for this type of lettering? Yes. This type of lettering is known as Gothic. Very, very important. This is Gothic type of lettering. Okay, in examination you can expect the type of lettering we use in drawing is Times New Roman, Calvin, like that I will ask. I go down switch. Go. Okay, this is about lettering. If it is inclined lettering, all the alphabets will fit like that. Okay, suppose A will be like this. Okay, like that will be there. And vertical lettering and inclined lettering. Of course, there is numbering also, but we don't need to expect any questions from numbering. Numbering there will be not much questions. There is not that much important in IES exam point of view, but in IES exam point of view, these are very, very important, too much important. Okay, see, the height is 10 mm, the form is width is 7 and the gap is 3 mm. So how you will take this? You have a formula. To find out the width of the alphabet, 3/4h. To find out the gap between two alphabets is 2/7h. Okay, now you got it. Okay, please note it down. So the next concept is line division. The very most important. Without help of line division, you may not be gone through any topic. Okay, in your academic drawing session, but here you just need to know about this one. You are not going to draw it at all. Okay, so what is the line division? You know, if you want to divide any line, suppose there is a line AB which is having length. You don't know about the length of this line. If you know this 100 mm, then you can divide this one into 10 parts. If it is 50 mm, also you can divide it into 25 parts, or you can divide it into 2 number of parts, or you can divide this one into 10 number of parts. Okay, you know, but here you don't know about the length of the line. So how to divide the length of this line? If I want to, let us say, if I want to make n number of parts, that n number of parts are 7. If I want to make this AB into 7 number of equal parts, how I will make it? Okay, so for this purpose, what I need to do, I need to draw a line from A or from B. Okay, the angle will be acute. Angle should be acute. What is acute? There are two types of angles. One is acute angle, another one is obtuse angle. Acute angle means less than 90 degrees. Okay, obtuse angle means greater than 90 degrees. Okay, that means from 1 to 90 degrees is considered as acute angle. Okay, obtuse angle means greater than 90. That means from 91 to anything. If it is 90 degrees, then it is perpendicular. That's different. If it is 0 degrees, it is a horizontal line. That also we are not going to consider 0 and 90. We are going to consider 1 to 89 as an acute angle. So draw an acute angle of any length. Of any length. So here what we will do is, with your compass or divider, take any of the radius. A as center, cut this one. Make this point as 1. Without changing that radius, with 1 as center, cut it. 2. With 2 as center, 3. 3 as center, 4. 4 as center, 5. 5 as center, 6. 6 as center, 7. Okay, this type of cutting process is known as progressive cutting. This type of cutting is known as progressive cutting. Why? Because of the radius is common. Okay, here with A as center, we are cutting 1. With 1 as center, without changing the radius, we are taking 2. With 2 as center, we are making 3. Okay, okay, what you have to do? Join B and 7. Join B and 7. Put your draft scale here and fix it. Then you will draw. If you drag your drawing scale at 6, then you will be able to draw a line from 6 which is parallel with 7. Next, 5, 4, 3, 2, 1. Okay, then you divided this line into equal number of parts. 1, 2, 3, 4, 5, 6. This is the 7th one and this is the 0th. Okay, this is how you do line division. Okay, so next thing is, sir, they will ask you, if the line is divided into 1:4:5 ratio, the line is divisible in 1:4:5 ratio, then the number of equal divisions we can make on this line will be 10. How, sir? It's 1 plus 4 plus 5. Okay, clear? So if a line of having length L can divide into m:n:4 ratio, then the number of equal parts we can do the line, we can do it on line E will be m plus n plus 4. Okay, if it is 1:5, then it's fine, it will be 6 parts. But it is 1:4:5, so you need to add all these things. Okay, clear? So this is about line division. Sir, you can ask me one now. Sir, can we divide line into only equal number of parts? Are we able to divide line into unequal number of parts? See, for the purpose of unequal number of parts, we don't need any process. You can directly make it. But still in drawing, there is a process. Okay. What you should do? See, this is the line length here. If you want to make it into unequal number of parts, you just need to construct a rectangle like this, close this one. Okay, then what you have to do, you have to draw a diagonal. You have to draw a diagonal, which is A, B, C, D. A, B, C, D. Okay, so now what you have to do, take the midpoint. How you will take the midpoint? Draw another diagonal, okay? You will get the midpoint. So, if you project it like this, then this line AB is divided into two number of unequal parts. You can see, okay? Sir, not like this. Now I want more number of parts. If you want more number of parts, you do one thing. Okay. Next, what you will do is, number of parts, what you will do is, here it is cutted now. This is O1. Next, draw a line from O1 to D. Draw a line from O1 to D. Okay. If you draw a line from O1 to D, you should perform perpendicular bisector method, then it will, so not perform perpendicular bisector, it's already cut it here. So the cutting point will be O dash here. Okay, now this line is divided into 1, 2, 3, 3 number of equal parts. If you want again, from here, now it is divided into 4 number of equal parts. So like this, you can divide a line into any number of unequal number of parts. Okay, clear?